Hey, Sarah.
Hi, how are you guys today?
Sarah, it's really awesome to see you.
You too, Joanne. I'm so happy to see you again. Yeah, the pandemic has made it time fly by, right?
Yeah, it has. All right, you guys, if you're comfortable showing your faces, it would be really awesome for Sarah because it is really hard to teach to a bunch of names written up there. So if you're comfortable showing your picture, that would be really awesome. And Sarah, I am recording this. I think you said that you can come to the evening section, but if for some reason you can't, I could show your video. So you could let me know at the end or now if you have time or not to come to the evening section.
Okay. Yeah, if you're recording, no, I'll come. I'll come. I think it'll be
Okay.
more fun for everyone
Okay.
if I
All
come.
right. Thanks, Sarah.
Yeah.
Okay. And now what I'm going to do, Sarah, is I think I need to pin you so that students see when the video will have you and what you're showing in your screen rather than when other people interject and ask questions. Okay.
Okay.
All
Wait.
right. So I'm going to turn it over to you, Sarah. Tell me what, yeah,
Okay. And bring your shared window to the front. What are you guys seeing?
what what I see is I see your presentation, but it's a little skewed.
That's what I see as well.
Does it look like it's in PowerPoint or does it look like it's in Chrome?
Ah, now it's okay.
It's in
Uh,
Chrome.
it looks like,
Somehow I've ended up in Chrome, but I think we can work with it.
yeah, I think it looks great.
Okay, super. All right. Well, hi everyone. My name is Sarah Hulick. I used to work. Oh, there we go. Okay, I'll have to be careful. So I used to work with Joanne full time at Cabrillo, and I still work at Cabrillo a little bit, doing some curriculum writing for career and technical ed. And just so you guys know, I can't actually see you anymore because now all I'm seeing is my screen. So maybe you can just speak up if you have a question. And so I am a plant scientist by training. And my background is I grew up on a farm in upstate New York. So I always tell people New York is actually really similar to California, where there's a city and some like major metropolitan hub. In California, there's two, there's San Francisco and LA. And then the entire rest of the state is literally like farms and mountains and stuff. And New York is the exact same way. So there's New York City, and then the whole rest of the state is farms and mountains. And I'm from a small farm in upstate New York. And then I went to college at Cornell University, which sounds very fancy, but honestly, if you're from New York, going to Cornell is kind of like going to maybe like UC Davis here in California. And they do have the agriculture school there. So I went to the agriculture and life sciences school and studied plant science. And then I got my master's degree from there also in horticulture biology. And the reason I got my master's is because I basically like wanted to be a scientist. That was my goal. And I love growing plants and I love feeding people. I love food. And I always kind of wanted to make sure that people had enough food and that there was more food for everyone to eat. So that's kind of my background. And then after I finished my master's degree, I got recruited by Driscoll's Strawberries, to move out here. And so that was 8 years ago in 2013. And I got recruited pretty much straight out of grad school to come take a job with Driscoll's. And I moved to Santa Cruz County, and I've been here ever since. And I just love this area because there's so many really good jobs. And that sounds funny, but talk about adulting is like you just want to like live somewhere where it's beautiful and the weather's good and there's great jobs. And for me, as someone who's in agriculture and in agriculture science and ag tech now too, this is where like the best jobs in the country are, for sure. And there's something really beautiful about being at this kind of nexus of production agriculture and next to Silicon Valley. So currently, my job is grower innovation manager at an ag tech startup called Full Harvest Technologies. And Full Harvest is basically trying to build an online marketplace to buy and sell produce online. And right now, produce is bought and sold. You think about Amazon and you just go on and buy a t-shirt and you want the purple one and you want it in a size medium. And it's like that simple. And it shows up at your door 2 days later. Produce isn't like that. It's all, old guys calling each other saying, I want 40,000 pounds of mandarins. Well, too bad they're stuck at the border and you can't get them till next week. And it's very like hands-on and all on the telephone. And so basically Full Harvest is trying to disrupt that. And so I made this slide deck a couple of years ago, and all the pictures in it are from Cabrillo. So this is very much like what is happening at Cabrillo. But I would say now that I've worked at Full Harvest for a couple of years, I actually have a very new perspective on like software engineering and ag tech, which isn't really encompassed in this deck. So I would like to share that now. And one of the things I realize is like, to be a software engineer, to be a hardware engineer, you can work on anything at all. Like, you can be a software engineer and work on automating, in and out orders at a hand sanitizer, manufacturing facility, or you can build anything, you can work. But so what I would say, what I think you all should think about is, if what I want to do with my life is coding, if that's what I love, or if I'm really into like optical stuff, well, what do you want to do with that? Like, what industry do you want to be in? And you can do like optical, audio visual engineering stuff, and you could do that for drones, for the military, or you can do that for like in this picture that's on the screen right now, you can do that for like optimization of crops in a greenhouse so we can feed people better and we can be better responsible stewards of all the inputs, all the fertilizer and pesticides and everything else and water that's being used. So it's kind of like, you guys all have as future engineers and current engineers, you have this like really amazing skill set. And then what are you going to do with that in the world? And like, you can, same thing, like if I was talking to students in the accounting program, you're going to crunch numbers anywhere, but what industry do you want to make better? Like, what is your stamp you want to put on the world? So for me, I think agriculture is an amazing industry to be in because it's like one of the world's biggest pressing problems is basically like, how do we decrease the environmental impacts of growing our food? And there's this organization called REFED, it's REFED, and they are kind of the current leader in understanding food waste and agriculture impacts on climate change. And their newest set of analysis is showing that decreasing food waste is actually the #1 way to decrease climate change effects in like the next few years. So all of their stuff is a roadmap to 2030. So it's like in the next 9 years, what are the things we could tackle that would decrease the effects of climate change immediately? And so their top one is decreasing food waste. And that requires a lot of different types of engineering. You could focus more on water, you could focus more on harvest aids, which is more hardware, you can focus on software. There's like so many, you can focus on chemicals. There's so many different areas that tie into that. And like I talked about before, jobs, 11% of jobs in the US are somehow related to agriculture. And this location is a really amazing one to get really good jobs. So these are actually the greenhouses up in the horticulture department at Cabrillo. And we do a lot of really cutting edge research on LED lighting and even beyond the visual spectrum of what humans can see. UV lighting and things like that to really optimize crop development. And there's a lot. If anyone in the class is from South County, from Watsonville, you see the fields and fields and fields. And some of you may be familiar that there's actually quite a labor shortage for agriculture, and those jobs are really hard and really backbreaking, and people don't want to do them, and rightfully so. And, there's a lot of companies that are developing these automatic pickers right now. And that is going to be the future of agriculture. I do not think in 20 years we'll see a lot of these, even these really fragile crops being picked by hand. I think they'll all be picked by robots because the people are not there, and we just need to automate so that, you know, the crops can keep getting produced, basically.
Sarah, could I interject for a moment?
Yeah. Uh-huh.
I wanted to mention that when Sarah talks about the automation that's happening in picking, so what the United States is trying to do is to train more people on the technology, because there are going to be so many more jobs in technology that, as just like you guys sitting in engineering 5, the more engineers, the more computer scientists, the more people we train in education and technology, people are just going to have those kind of jobs instead of the back-breaking jobs of picking.
Yeah, absolutely. And that is the goal. You know, there's a new you know, Joanne led this charge of creating a new sustainable agriculture technology degree at Full Harvest, and that's what I worked with her on there. I'm sorry, at Cabrillo College, excuse me. And it includes the How Things Work class from engineering, and it includes some programming classes. And actually now I think we settled on Python as the language that we thought was the most kind of cohesive for most agricultural applications. Um, and you know, this kind of skill set where you know a little bit about producing food, or at least just kind of like the operational aspects of what's important, but actually being more of a computer scientist or an engineer is really, really key. And the images on the screen right now are this is all at Cabrillo, and we have a aquaponics set up. And in the picture on the right, all these cages, and I mean it's hard to see because, you know, it's from so far, but basically this is all, we're using all sensors to determine what's happening right in the ponds that we're growing the lettuce in, and in the fish tanks that are feeding. You know, it's like we feed the fish poop, and the fish poop feeds the lettuce, kind of thing. And so 5.7, that's like the pH, so that's the acidity of the water. And you know, we're monitoring all this stuff in real time. And that's that kind of skill set of like, who can set up these sensors, who understands, who can interpret this data, and then who can make an operational change based on that. These are all the things. This is what, you know, farms will look like in the future. And this is the stuff I get really excited about it. I hope other people find it exciting, because we're definitely going to need people to be, you know, these high tech ag tech engineers and ag tech technicians moving forward. Great. I think I already talked about microcontrols and sensors. There's energy monitoring going on in one of the greenhouses. I think Karen Grappi was leading that a couple years ago. I'm not sure if it's still happening. And then we have a new vertical farm too, where everything is indoors completely. This is the outside. It's not as exciting. It just looks like a box, but inside it pretty much looks like this. I think we have 3 layers in there, and literally just figuring out, how do we grow plants completely indoors, and just like kind of problem solving. And you got to think about how much water plants need. And water is really, really heavy. And so that's a very interesting engineering conundrum, is like, you know, this is Cabrillo, and this box is about 12 feet tall. But think about, they're actually retrofitting huge warehouses with, you know, 10 layers of this. And then you actually have 1 million pounds of water in that vertical space. And how do you kind of solve for all of those issues also? And then if you're more interested in this, I have a couple, and Joanne can share this slide with everyone, because I know we're going really fast and there's a lot of information here, but there's a couple classes listed at Cabrillo that might be interesting if some of this stuff is really like kind of intriguing you all. And then we've got a few more, I've got YouTube video links in throughout these slides too, and you can take a look at some of this stuff a little bit more. This is my email. Currently, I'm no longer the agriculture technology specialist. I think my current title is career and technical education consultant or something like that. But this email is still correct for me, and I'm really happy to answer any questions anyone has. Oh, and then this is actually, here's a perfect engineering problem right here. this is me in a greenhouse I used to manage in Marina. And we are growing that lettuce, which is the type of stuff you'd see in those fancy bags of lettuce. And we didn't have a way to harvest it other than, this is me bending over in a terrible position, my back would hurt at the end of the day, cutting it with a turkey carving knife. And so what we really needed was a whole set of like rollers so that these channels could roll around the greenhouse and go through some sort of automated cutting machine. And that was kind of like our future hope and our future goal, but we didn't have, kind of like the capital and I'm a plant scientist, so I know how to grow that lettuce, but I don't know how to build, an automatic cutting machine. And that's kind of what we need some of you engineers to, hope to want to do someday, is to optimize some of these newer technology systems. I'm going to stop sharing so that I can look at you all, and then I would love to answer any questions. All right. I know that was fast. I kind of talk really fast because I'm also from New York, like Joanne. But any questions you guys have?
So Sarah, I know you sent me the PowerPoint, so I could post it on the Canvas page for everyone. So
Yeah.
I'll do that.
That'd be
So
great.
what are some questions, you guys?
I just want to say thank you. That was a really fascinating. I had never even thought about robotics and agriculture before. That was really cool. I'm kind of interested in what is it? Mechatronics. I'm thinking about getting into mechatronics. So I hadn't even thought about that aspect of it. Thank you.
Yeah, absolutely. And for sure, this area we're in is the hub for ag tech. So there's Salinas is basically the ag tech hub in the US, I would say, just because of its proximity to Silicon Valley. So, the investors and all the big bankers and everybody can come down really easily. And you have access to fields and space so people can test their new ideas. And a few of the things I've seen recently that are, really interesting is like, there is this new sprayer where they actually use magnets so that they can get the water droplets to be the exact same size and go an exact distance in the field. There's a lot of software stuff because a lot of times farms aren't actually optimized, honestly, about what's your forecast, what's going into a cooler, what's leaving the cooler. And so right now, I'd say there's a lot of actual software companies that are literally just doing that kind of like, we have X tons of this, we have Y amount of packaging, so-and-so needs to get it to, Z field by Monday. And that just like operational efficiency software. There's a couple of companies like that based in Salinas. And then every single one of the huge ag companies like Dole or Taylor Farms or companies like that, they build their own harvesting equipment. So they all have, like, when I worked at Dole, I was an agronomist, and we were underneath the same kind of group in the company as all the engineers. And they would build their own, literally from scratch, harvesting machine to like harvest celery. And like, those are very good jobs. It's very interesting work. You're being asked to invent something new, like annually, like, oh, good, you made that for us, we love it, but we want it to look like this next year. And so there's actually a ton of ag tech and ag engineering going on in this area, I would say. And I live in Watsonville, so I'm not calling in from some other part of the world either. So, I've found lots of great ag tech jobs right here.
Sarah, I love what you said about, you could get a degree in programming and then you get to choose what industry you want to work in. And we've talked a lot about that in engineering with these broad jobs like chemical engineering or software, where you get to choose, do you want to work for the military? Do you want to put food on people's tables, And I think at Cabrillo, because our engineering program's all about humanitarian engineering and engineering is a helping profession, I think a lot of students come to Cabrillo because that's what their interest is as well.
Yeah,
All
absolutely.
right, do we have any other questions for Sarah?
Well, I just thought throughout presentation of how different companies use, like for example, strawberries, and they have different varieties, how they use the chemical processes of making, let's say, from red strawberries to like, in a sense, bigger strawberries, or lettuce. And I thought that was really interesting because it requires a huge process of actually just getting something to be something else. Like for example, you want something that's going to be able to grow in a rigid place, or if you want something that's from a dry place to be in a humid place. And I thought that was super interesting.
Yeah, absolutely. And a lot of that, and I'm sure all of you are very aware of, climate change is real and it's happening today. And I've only lived in Santa Cruz County for like 8 years. And I feel like I've seen differences. And the summers are way hotter now. And even today, it's going to be like 75 degrees today. Like that's not normal, right? For we like live on the coast. It should be more mild than that. And so I think what you're saying, Luis, is like, these things are changing, and a lot of people will be getting paid, having careers, and figuring out how do we optimize those changes.
Sarah, I just saw Carlos said that, he feels like the winter is getting shorter, that he's experiencing it too. What about, I think Luis, you mentioned something like genetic engineering, genetically modified, like making the best strawberries. Could you talk a little bit about what that's like? Or
Yeah,
like
sure.
making a better strawberry, is that has to do with plant science and engineering together, or no? Or making a better tomato, or?
Yeah, this is a great question. So I would say, the tradition, there's like plant breeding is what we're talking about when we're like, oh, we're going to make a strawberry that's slightly larger, or it can deal with slightly drier weather. And there's a lot of traditional ways to do this. Like this is what humans have been doing for millennia, right? That's why it's really weird to think about, but like broccoli, cauliflower, cabbage, Brussels sprouts, those are all the same like species. It's like humans have, oh, we like that this one has the bigger head, so then we just plant that one, and this is called traditional plant breeding. And that's still what is the most common today. But there is, genetic modification happening, I would say more at like research universities and more like institutions like that. But and that's really more of a traditional plant science background, but where an engineer comes into this, and this is what's really interesting too, is what plant breeders are trying to do is create the best plant for any given environment. But now that we're getting more into robotic harvesting or growing in greenhouses, those environments are shifting a lot. So they'll use someone with an engineering or a systems engineering background to figure out the perfect combination of environment plus the genetics of the plants. So for example, strawberries had always been grown in the ground until very, very recently. And then a couple of years ago, they started actually growing them in these like channels that are actually at like waist height in a field. And part of that was for harvest efficiency so that people don't have to bend over to pick those strawberries. But really, if we really think about where is this going to be in 10 or 20 years, there won't be people picking those. So what we need is, those channels need to be designed in such a way that eventually a machine can pick them. And a lot of times it's like very incremental. Okay, now we have the channel, but there's still people picking them. Okay, well now we need a new variety, or this is like a breed in dogs. We need a new breed of strawberry that actually has a longer stem, so it falls below the channel so that something can go through and clip it off. And this is like the interface of where the engineers and the plant breeders basically interact to figure out what does the hardware and the optical software, what does all that look like with our best plant genetics to make the whole system work.
That's so cool. So cool.
Yeah, it really is. There are so many problems to be solved. And I think a lot of them are really fun in agriculture.
Yeah. Yeah. Okay, Sarah, I'm going to say thanks so much. And I'll see you this evening in the other class.
Cool. Great.
Okay.
Thank you, Joanne. And thank you, all of you. And hope you're having a wonderful Thursday. And hope I convinced maybe one or two of you to think more about ag as your engineering focus.
Thank you, Sarah.
All right. Thank you. Have a good one.
Thank you,
Have a
Sarah.
Thanks, Sarah.